This unit focuses on a review of measures of central tendency and measures of dispersion. For the purposes of this class, we're going to be doing primarily univariate and bivariate data analysis. Univariate analysis is the what of data analysis. It means looking at one variable to give an overall description of that subject population. Your goal here again is to describe the population. You might use measures of central tendency such as the mean, median, and mode, or measures of dispersion such as the standard deviation. Bivariate, or two variables at once, gives you the why of the data. It looks at the relationship between two variables. Here, your goal is explanation. How does one variable impact another? You might be using crosstabs or measures of association and tests of significance. I'll be covering those in depth later in the class. How do you know which tests and statistics to use? This, as was discussed in a previous unit, depends entirely on the level of measurement of the variables involved. Remember, if you recode a variable, you've probably changed the level of measurement. The types of questions you ask about nominal, ordinal, and interval ratio or scale level variables are substantively different. You use different measures of central tendency and different measures of dispersion. Measures of central tendency tell us something about the center or midpoint of a distribution. If you have a nominal variable, meaning there's no center or midpoint, it tells you how people are distributed. It's a single value that tells you something about the variable. Which measures you use depends on the level of measurement of the variable involved. The median, the 50th percentile ranking, and the mean, the arithmetic average. Which one or ones you use depends on the level of measurement of the variables involved. The mode is the most frequent or common value in a distribution. It's the only measure of central tendency that can be used for nominal variables, or variables that have no rank order. It can also be reported for ordinal and interval ratio level variables, but it may not be appropriate. In the example you see below, I have political party identification. In this case, Democrat is the modal category because there are more people in that category than any other. The median is the position average, or the point that divides a distribution in half, the point at which half of the values are above and half are below. It cannot be used for nominal variables because there is no ranking or order. For ordinal or scale interval ratio level variables, however, the median certainly can be used. Take any Likert scale as an example. Below you can see I've had people rank their agreement from strongly opposed to strongly support. In this case, the median is in the category for support because the 50th percentile point is somewhere in that category. What this means is you sum all the values and then divide by the total number of cases. The mean may only be used for interval ratio or scale level data. If you need to calculate a mean, you would simply take each person's score, add them up, and then divide by the total number of people. Here I have an example of midterm scores. I've added up each of the students' scores on the midterm and taken the average, and we can see that the average midterm score out of 100 was 79.7, or right around a C plus, B minus. When a distribution follows the normal curve, we expect the mean, median, and the mode to be the same. So how do you know which to use, the mean, the median, or the mode? The key issue in this assessment are the level of measurement of the variables involved. If you have a nominal variable, you can only use the mode. If you have an ordinal variable, the median is probably your best choice, and if you have an interval ratio level data, the mean is your best choice. However, you should also consider the shape of the distribution and the purpose of your statistical summary, because there are some special cases in which you might want to use the median instead of the mean for interval ratio level data. If you have interval ratio or scale level data, usually the mean provides the best information, especially if the distribution is normal. However, you might be in a situation where you have what we call skew, meaning that there are some very high or very low values affecting the mean. As I just said, skew refers to a few very high or very low values that affect the value of the mean. We call this having a very long left or a long right-hand tail. The classic example in the social sciences is income. With income, there's a 0 point where it starts, but really, you can have a maximum income of any value. And what we tend to see is that most of us make within a certain amount. However, a few of us make a lot more than everybody else. Here's what a typical income distribution looks like, and you can see there's definitely more values to the right that are going to pull the average up higher than it really should be, or than what really reflects how much money most people make. Here you can see the effects of skew. Notice the mode is largely unaffected. The median is only affected a little bit, but the mean gets really pulled by some high or low values. Because of this, when we're dealing with variables that have a lot of skew, we'll often report the median in addition to the mean. With income in particular, you'll want to report the median rather than the mean. Are best for interval ratio or scale level variables. They provide information about how spread out or how tightly clustered data is, and they capture the shape of the distribution. Distribution. Because the range can be affected by one very high or one very low value, it's not an adequate measure. So take, for example, the variable age. If the youngest participant in our sample is 18 and the oldest participant is 97, then the range is from 18 to 97, or 79 years. The average squared deviation of each case from the mean and summing them, then dividing by the total number in the sample minus 1. It takes into the account the amount by which each case differs from the mean. We can't just take the distance of each value from the mean, because if we were to sum those up, by definition it would equal 0. That's why we have to square it. However, if we were to just use the variance, it would be made artificially larger by the act of squaring it. This is why we actually generally use the standard deviation instead of the variance. So don't worry too much about the variance. You should have covered it in some of your previous classes, and this is just a review. The standard deviation takes the square root of the variance. It gives us the average amount each value varies from the mean. The larger the standard deviation, the more spread out a distribution is. The smaller the standard deviation, the more tightly clustered around the mean a distribution is. As a general rule, if a distribution is normal, we expect 68% of respondents to be within 1 standard deviation of the mean, 95% to fall within 2 standard deviations of the mean, and 99% to fall within 3 standard deviations of the mean. 95% are within 2 standard deviations of the mean, and 99% are within 3 standard deviations of the mean. What we're trying to get across to you there is that, let's say I know the mean. Let's say I know the mean score on the midterm. Let's say it was 79. If I know that the mean score on the midterm was 79, and that the standard deviation was 5 points, I would expect 2/3 of the class to be between 74 and 84 on the midterm. In the upcoming units, you're going to learn how to create cross-tabulations. A cross-tabulation is how one variable is distributed across another variable. Sometimes they're called contingency tables or two-way frequency tables. For bivariate data analysis, we want to keep in mind that for using SPSS, for some of the tests we're going to run, it matters to the computer where you put the dependent and where you put the independent variable. Hence, for this class, we're going to follow the Dr. Ick rule, meaning we're going to put the dependent variable in the row for our cross tabulations and the independent variable in the column for our cross tabulations. This tells us that we should always be asking for column percentages when we perform our cross tabulations. If this is all Greek to you, I'll go over it in the lab.